Alright, so today is day 7 and the last day of the first week in the Leetcode 30-day daily coding challenge. The question today is counting elements. It's also a relatively easy question. We have an integer array as the input. We need to count the element x such that x plus 1 is also in the array. If there are duplicates, we should count them separately. We have full example here. The first one is 1, 2, 3. We find that 1 and 2 exist in the array, so we add the number of times that the 1 appeared, which is 1, and we have 2 and 3, so we add the number of times that 2 appeared in the array, so 1 plus 1 we get 2 here. Then we have 1, 1, 3, 3, 5, 5, 7, 7. Since there are no adjacent integers that appeared in the array, we output 0 here. The third example, we have 1, 3, 2, 3, 5, 0. We have 0 and 1, so we add the number of times 0 appeared. We have 1 and 2, we add the number of times that 1 appeared. We have 3 and 2, so we add the number of times that 2 appeared in the array. So that's 1 plus 1 plus 1, we get 3. There is no 4, there is no 6, so we couldn't add the times that 3 or 5 appeared in the array. So the final output is 3 for this input. As for the very last example, we have 1, 1, 2, 2, so we add the number of times that 1 appeared, which is 2 here. So just based through how I read through the examples, we know that it might be useful that we just pass through the array once to generate the frequency count for the unique integers. So we will populate a hash map with the key be the unique integers in the array, and the values will be the number of times that particular integer appeared in the array. Then that's just one pass through the array to generate that hash map. Then we iterate over all the keys and to see if the key value plus 1 is in the hash map or not. If it's also in the hash map, then we just increment the output counter by the value associated with that key. So this leads us to a linear algorithm in both time and space. In time, because we do one pass to generate the hash map, and the other pass to go through the keys in the hash map to do the testing, increment the counter. That's the second iteration. It's the second loop is linear in the worst case. So there's 2 linear paths in the worst case. So that's for the time complexity. For the space, the hash map will consume at most order of n in space, so it's linear in both time and space. Yeah, I guess if you would ask us to if you want a constant space solution, it's possible, but we might need to sort this thing. If we can sort the array, then we can iterate over the numbers in here. And whenever we see duplicates, we just keep track of how many times this particular number appeared. And then when we see the next number is different, we test if the gap is 1 or not. If it's 1, we just add that difference, add the number of times this previous number exists, the number of times that we have seen this previous number. Otherwise, we'll just reset the the duplicate number duplication counter, and that algorithm is n log n in time, because we have to sort the array, but it's constant in space. Yeah, let's code the both solution up. So let's code the linear solution first. We have a hash map of integer and integers. Let's call it table. The keys are the unique integers in the array, and the values are the number of times that that key existed in the array. So we go through the array just once to populate this hash map. And then we go through all the keys and do the key +1 testing. Table. If table find key first, we get the key value +1 if it's not the end. Then if that's the case, then we increment the counter. So let's try submit this one. Okay, so this is the first solution, which is linear in both time and space. Let's code the constant space solution as well. So what we do is to sort the input array first. And then we initialize something to store the number of times that we have seen the current number. Let's call it strike. Yeah, maybe one. One is better. Or size. So if this number is larger than the previous one, and by exactly 1, we increment the counter by the value of the strike variable here. I is and we have to also to increment the strike only if that we have to increment it only if we have seen a tie. So otherwise we just reset this to be 1 because we basically are going to a new number now. So let's submit this solution as well. Yeah, so this one also works. So ON. So yeah, so these are the two solutions. Okay.